functionality में we'll see the difference in the characteristics of hub and a switch. Got it? So this is a hub. This is a hub. And this is a switch. So let's see the difference. First of all, I'll give configure IP address in all these PCs. Let this be 10.0. Zero dot two. Sorry. 10.2. Let the IP address be 10.0.0.3. 10.0.0.3. 10 dot. Okay. Now we'll mainly discuss about single broadcast domain, single collision domain, half duplex, okay. So let's see. So what happens since it is a half duplex? Hub is a half duplex. So if two PCs, let's suppose this is sending a data and this PC also sends the data at the same time, what will happen? The data will collide. Collision will occur. Why? Why? Because the media is because the media is half duplex. So data cannot travel in both the directions at the same time. So if data will move in two different directions and the path is half duplex, that means they have to collision. They have to collide. They will collide. The data will collide. collision will occur. Getting my point or not? So let's see this point. I'll send, sitting from the first PC, I'll send the data to the last PC. Got it? Let me switch on the simulation mode. And we'll see, we'll observe many other things too. So, and at the same time, we will send the data from last PC to the first PC. Let's see what happens. Okay. So the data is colliding. Getting my point or not? Collision occurred and every device came to know that collision has taken place. Getting my point or not? Don't look towards the switch. That is a different part. We'll discuss that later. अभी हम लोगों को we have to discuss everything related to this part, the hub part. So what's happening? If we are sending the data in two different directions, collision is taking place. Data collide कर जा रहा है. Getting my point? Why? Because it is half duplex. We have already discussed why the collision will occur. Getting my point? समझ रहे हो ना इस बात को? तो and see, if we are sending if we will send the data at the broadcast address, see what happens. Let me ping okay, 255.255.255 is the broadcast address, or you can say 10.255.255.255 is the broadcast layer 3 address of this network, of the network these PCs are into. Getting it? So they are in 10.0.0.0/8 network. So the broadcast address of this network will be 10.255.255.255. समझ में आ रही है ना बात? ये broadcast address होगा. So in this case, if we are going to send any data from the first PC at the broadcast address, let's see what happens. Enter. Now see. So there was no ARP request. Can you tell me why? आप लोग बता सकते हो कि ARP रिक्वेस्ट क्यों नहीं आया? डायरेक्ट डेटा सेंड हो गया, ARP रिक्वेस्ट क्यों नहीं आया? देखो छोटी छोटी चीजें हैं, these are very small points, but these are very important. You must remember these things. Let's suppose this is a hub. One PC is connected to it, other PC is connected here. Third, let it be 10.0.0.1, 10.0.0.2, 10.0.0.3, and 10.0.0.4 slash 8 slash 8 slash 8 and slash 8. जब आईपी एड्रेसेस पढ़ाऊंगा उस समय आप लोगों को ये स्लैश 8 वगैरह का मीनिंग समझ में आ जाएगा। अभी केवल आईपी एड्रेस लेयर 3 एड्रेस आप मान के चलो। तो यहां से मैंने मैसेज भेजा एक, यहां से मैंने मैसेज भेजा सोर्स 10.0.0.1 and the destination is 10.255. Let's suppose this is the data. It came to layer 3 and layer 3 address was added, that is 10.0.0.1 and destination be 10.255.255.255. This is the broadcast address. Layer 3 address. So we have already discussed that we supply the destination IP address, but we do not supply the destination MAC address. Source MAC, let the MAC address of this PCB AA. We do not supply either source MAC or destination MAC. We supply only the destination IP address. Okay, I wrote ping 10.255.255.255. In the class, I told you if a PC, let's suppose if I ping from this PC, if I ping ping 10.0.0.4, what will happen? A data will be generated. A data will be generated, ICMP data, ICMP. Here we have ICMP data. And then IP address would be attached, source IP be 10.0.0.2 and the destination address would be 10.0.0.4. Then this PC will go and check into its ARP cache. If it has the MAC address for 10.0.0.4 or not. If it does have, let's suppose the MAC address of this PC is DD. If it does have the MAC address, it will pick this MAC address, copy it from here to the destination MAC as DD, and it will attach, let's suppose its MAC is BB. It will attach the MAC address, source MAC as BB, and it will deliver the data. It will send the data. Getting it? But if it does not have the entry into the cache memory, ARP cache, what will happen? It will just keep this data aside. It will keep this data aside, and it will just generate an ARP request. It will generate an ARP request, MAC of 10.0.0.4. What is the MAC address of 10.0.0.4? In source, it will write BB, and in destination, it will write FFFF, layer 3, layer 2 broadcast address. Getting it? It will release this data through this wire, and it will be broadcasted everywhere. It will be broadcasted everywhere. All the PCs will ignore it, but this PC will reply because the entry into, because the target MAC address, the MAC address this PC is looking for is for 10.0.0.4. So this PC will see this IP address and it will say, oh, it's meant for me. Someone is trying to know my MAC address, isn't it? So what will it do? It will just send an ARP reply, REPLY reply with its MAC address as an answer. My MAC is DD and the source MAC would be DD and the destination MAC would be AA. Who is asking for the MAC address? Oh, sorry, BB. So BB, and this reply will go and reach this PC, and then this PC will write down the destination MAC address, destination MAC as DD and source MAC as its own MAC address, that is BB, and then it will send this real data. Then it will send this real data to this hub, and hub will finally again broadcast it. But see, यहाँ पर इस कंडीशन में nothing happened as such. I just ping 10.255.255.255. It does not have MAC address for 10.255.255.255. Here it did not go to check in the ARP cache. ARP CACHE cache. It did not go to check in the ARP cache for the MAC address of this destination. Neither did it send any ARP request to know the MAC address of 10.255.255.255. It did not send any ARP request. Getting my point or not? It simply, what did it do? This PC do? It simply just wrote FFFF as the broadcast address and send the data to the hub. समझ रहे हो या नहीं? समझ में आ रही है बात?
Yes, sir.
इस एड्रेस के लिए इसने ARP रिक्वेस्ट नहीं किया, इसने सिंपली मैक एड्रेस लिख दिया FFFFFF. Why? Because this PC knows that this is a broadcast address, and therefore we have to supply the broadcast MAC address as layer 2 address. Getting my point or not? As layer 2 MAC address, and it just delivered the data to the hub. Now what will happen? Hub cannot read this address, neither this address nor this address. So it will just broadcast it. It will send it to all the devices attached to it. मैंने ये चीज आप लोगों को पहले भी समझाया है. It will just send it to all the devices. Now let us check. Let us see. See, the source address is this and the destination address is FFFF. Without sending any ARP query or anything, it simply attached FFFFFF as the broadcast address. Getting it? Why? Because the destination IP address is the broadcast address. Getting it? क्योंकि ब्रॉडकास्ट एड्रेस में तो सारे डिवाइस आ जाते हैं, तो सारे डिवाइस का तो मैक एड्रेस नहीं अटैच करेगा ना. All the devices are part of this MAC address, this broadcast address. So this PC cannot write the MAC address of all these individual PCs here, getting it in the destination MAC address in Ethernet format. So it just wrote FFFF. That means it is meant for everyone, all the devices. समझ में आ रही है बात ना? और इसने इस डेटा को रिलीज किया. Now let's come back. What will happen? This PC, this hub cannot read. This hub cannot read either MAC address or IP address. So what will this device do? It will send this data to all the devices thinking that whoever needs this data will accept it and others will ignore it. But what happens here? ये भी this device see that the destination IP address is 10.255.255.255. The destination IP address is 10.255.255.255. So I am also the part of this group. I am 10.0.0.2. So I am also part of this group. This second PC will say, I am 10.0.0.3 and I am also part of this group. This data is meant for me also. And this PC will also say that I am 10.0.0.4 and I am also part of this broadcast address. We are all the part of this broadcast address. So this is meant for me. This PC will say this is meant for me and this is meant for me. All these PCs will reply back. Getting it? लेकिन हमने यहाँ पे क्या सीखना था? We have to learn, we have to understand that if any port sends any data at the broadcast address, it reaches all other ports. It reaches all other devices that are attached to this hub. Therefore, we can say that all these devices are present in one single broadcast domain. Now see what happens. इसमें तो कोलिजन होगा ही होगा, आप लोगों को पता है. So we have discussed about the single broadcast domain of a hub. Now we will discuss about, and we have also seen what happened when all the devices send data at the same time, or at least two devices send data at the same time. The data collides. Why? Because it is half duplex. Only one data can travel at a time. Getting my point? Now let's come to the switch. अब ध्यान से देखना. Observe everything very carefully. Okay, be careful. See what happens when I provide IP address to any PC. In this example, we didn't notice that. But here, try to notice what happens when I configure IP address to any PC. Okay, so let us see. Now I'm just deleting this part. Now let's see. Just see. Just see what happens here. Just see what happens here when I type the address, some address in this device. Let it be 10.0.0.1. Okay. No sooner I configured IP address to this PC, it just generated an ARP request. Now you can see. Okay. Let's go inside and see what is written as a target IP address. So this PC, we have configured 10.0.0.1. इस PC में हमने IP एड्रेस डाला 10.0.0.1/8 means 255.255.0.0.0. यहाँ हमने जैसे ही ये एड्रेस टाइप किया, no sooner we typed an IP address 10.0.0.1/8, it just generated an ARP request for its own IP address. For its own IP address. See, the source is 10.0.0.1. Who is asking for the IP address? For the MAC address. And for what MAC, which IP address it is asking the MAC address for? it is asking the MAC address for 10.0.0.1. Means it knows that someone has supplied IP address 10.0.0.1 as my IP address. Now let me send an ARP request what is the MAC of 10.0.0.1. So source MAC will be the MAC address of this. Now as short I have to write, let me write AA is the MAC address of this PC. So AA and the destination will be FFFF. It will be sent to all other devices. So here we have a switch. I have already told you that switches always learn the incoming source MAC address. Switches always learn the incoming source MAC address. So let us see its MAC address first. Show MAC address table. This one it has learned. Why? Though it is not showing in the simulation, but this in real time it has reached the switch and it has learned that F0/1, that some packet has arrived at F0/1 and the source MAC address is this. This is the source MAC address. Copy. Let's copy it and let's check here. What is written here? See, 00097C89AZ. So this is the MAC address of this PC. So the source MAC address will be the MAC address of this PC, isn't it? सोर्स मैक एड्रेस क्या होगा? इस पीसी का मैक एड्रेस होगा. इस पीसी का चलो यहां से मैक एड्रेस देखते हैं. यही है इस पीसी का मैक एड्रेस. So this PC has attached its own MAC address as the source MAC address and the destination MAC address as FFFF, that is the broadcast address. That is the broadcast address. And it is asking for the MAC address of its own IP, for its own IP. The IP address that we have supplied into this PC. Why it is doing so? ऐसा क्यों कर रहा है? भाई ये अपने ही आईपी का मैक एड्रेस दूसरों से क्यों मांग रहा है? This is, it's asking for it's the MAC address of its own IP address because it wants to know whether this IP address has been configured in some other PC or not. Getting my point? ये चेक करना चाह रहा है कि क्या किसी दूसरे पीसी में सेम आईपी एड्रेस है. If it will get the reply from any of the PC in this network, it will just ignore this IP address, saying that somewhere this IP address has already been configured, so I will not accept this IP because confliction will occur later. एक ही colony में, in one colony, we cannot have two houses with the same address. अगर दो घर में, एक ही कॉलोनी में अगर दो घरों में H22 and this house also has the address H22. So confliction will occur if the postman comes and he wants to send a post or he wants to deliver some envelope or anything at H22, whom will it give? So this will be a big problem. Therefore, when we configure some IP address in any device, it sends the ARP request. That device sends the ARP request for its own IP address. It wants to check if the same IP address has already been configured in some other device in that network or not. Getting my point? So now let's see what happens next. It will be sent to all the PCs. Yes. See here also, in this case also, we see that if something has been broadcasted, it reaches all other devices. It reaches all other devices through the port attached to the switch. Therefore, we can say that all the ports are present into one single broadcast domain by default. Therefore, switches also have a single broadcast domain by default. But in switches, we can have multiple broadcast domain and group these interfaces or ports into different broadcast domains. That we'll see later when we'll discuss VLANs and all. Okay, so none of them are replying. It has sent an ARP request for 10.0.0.1. Getting my point? It has sent an ARP request for 10.0.0.1. It reached here, it said no, my address is not 10.0.0.1. This PC also ignored it, and this PC also ignored it. So this PC is not getting any reply for 10.0.0.1. Now this PC can confidently keep this address. It will say, okay, let me keep this address because this address is unique in my network. No other device has this IP address. समझ रहे हो ना? इसमें और किसी के पास ये IP एड्रेस नहीं है, तो मैं रख लेता हूं, कॉन्फ्लिक्शन नहीं होगी. अगर तबीयत ठीक नहीं है यार मेरी आज. Anyway, so let's check. Let's see what happened. चलो, ये इसने इस IP एड्रेस को एक्सेप्ट कर लिया, राइट? अब हम देखते हैं किसी दूसरे डिवाइस में, दो डिवाइस में हम सेम IP डालेंगे, ठीक है? तो इसमें मैं 10.2 डालूंगा, I will configure 10.0.0.2, and while it sends the ARP request for 10.0.0.2, we will configure the same IP address here also. Okay. And let's see what happens. No, we just configure. We have already configured 10.0.0.1 here. So now let's configure 10.0.0.1 in this PC also. And let's see what happens. Okay. So here we have 10.0.0.1/8. Let's configure the same IP address in this PC. And try to look carefully. 10.0.0.1. Got it? Now again, this PC has generated an ARP request for its own IP address. And it is asking the MAC address for its own IP address. Why? Because it wants to check if any other device is configured with the same IP that this device has been configured with. Getting my point or not? So now let's see what happens. One PC will reply with its MAC address. ये वाला PC इसको reply करेगा कि हाँ मेरा MAC address अभी outbound आने दो. This PC is replying back that my IP address is 10.0.0.1 and my MAC address is source IP is 10.1 and source MAC is this. ठीक है? So what will happen when it reaches here? Now it has reached here. Now let us see what happened with the IP address that we had configured. It's no more here. That means this PC, when it saw that someone else is having the same address, this PC has ignored that IP address, saying that I will not keep this address because confliction will occur. So just configure some other address in me. Now let us configure 10.0.0.2. 10.0.0.2. It will again send a broadcast request, ARP request. It will generate an ARP request for 10.2, and this time it will not get any reply. So it will keep this address thinking that there is no confliction. Let us see. Let's see the target IP. It's 10.2 and it's looking for the MAC address of 10.2 and it will not get any reply and it will keep this address. इसके पास नहीं आया कोई रिप्लाई. ये देखो इसने रख लिया. तो ये तो मैंने एक्स्ट्रा आप लोगों को अभी समझाया. What we have to see is that if this, now let me configure the IP address in all these devices. Now you have understood these things. 10, 10. see. It will keep this address because this is unique. And let me check what happened. Yeah, it has accepted. Accepted. Now let's see, since it is a switch, it is full duplex in nature. So no matter, even if all the PCs are sending and receiving data from all other PCs, it data will not collide because I have already explained you that from all ports to all other ports, there are paths to send the data and receive the data. They are separate path. So data cannot collide in this case. So let's see. Let's send the data from this PC to this PC, 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 from this PC to this PC. They are sending the ARP request. So don't bother about all these green packets. Those are the ARP requests just to know the MAC address of the destination address. Now is after the ARP request, they will send the real data and we see that they are not colliding. Getting the point? The data will not collide. Why? Because there are separate paths. Last time I taught you that from each port to every other port, there are separate path for sending and receiving the data. Like this. So if all the devices will send the data at the same time to each other device, collision will not occur. Getting my point or not? So it has no collision domain by default. By default, it has no collision domain, but it can have multiple collision domains. When can it have multiple collision domains? When we attach some half duplex devices. These are, let us configure them as half duplex. Let's see if we can configure. Yes, this is full duplex. Here we can see this is full duplex. So let us configure it as half duplex 10 Mbps. Okay. Let us configure this as half duplex 10 Mbps and let's see what happens. ये हाफ डुप्लेक्स हो गया. ठीक है, ये हाफ डुप्लेक्स हो गया. तो इतना सा पोर्शन this portion has become half duplex. Means only data can move in one direction here. it cannot move in both the directions. If it will move in both the directions, collision will occur at any point from here to here. So let's see what happens. It has not got configured properly because here we see this is still orange. Let us bring it to the real mode, real time. Let it get green first. Let's check it out if it's still half duplex or not. Yeah, it's still half duplex. Let it get green. Wait for some time. We'll have to wait for some time. Yes. Now let's check what happens when this device sends and receives the data. Oh, wait. Let us bring it to. Let's check now. No, it's not giving a proper. Yes, yes, yes. Now we can see that collision has started. If two data move in the same in different opposite direction in this cable, isn't it? No other place you will see collision, but in this you will see collision sometimes. When the data come in opposite direction, they start colliding. Getting the point or not? समझ रहे हो ना? समझ रहे हो ना कि कोलिजन
Yes.
कब हो रहा है? जब टू ऑपोजिट डायरेक्शन में डेटा मूव हो रहा है इस मीडिया पे, यहां से यहां तक के बीच में, जब दो ऑपोजिट डायरेक्शन में डेटा मूव कर रहा है, उस समय आप देख रहे हो कि कोलिजन हो जा रही है. जब एक डायरेक्शन में मूव कर रहा है तब नहीं हो रहा है. यहाँ पे अब ये CSMA CD का भी यूज कर रहा है ये पीसी. ये देख रहा है कि अगर डेटा हाफ डुप्लेक्स है तो लेट अस यूज CSMACD, और CSMACD की वजह से कोलिजन ज्यादा नहीं हो रही है. लेकिन फिर भी हमने दो बार देखा, ट्वाइस वी सॉ दैट कोलिजन अकर्ड. ठीक है, तो ये एक हाफ डुप्लेक्स यहां तक बन गया. सो दिस हैज बिकम अ सिंगल कोलिजन. Similarly, if we configure this PC also as half duplex, let's see. Let it be 10 Mbps half duplex. Okay. Now this media will also become a collision domain. This media will also become a collision domain. So one collision domain here, one single collision domain here. Likewise, as the number of half duplex media increases, the collision domain will increase. And finally, we will say that switches have multiple collision domains. So let us give some time to get this green, and then we will see the practical again. It will take some time. See, now you can see collision has started. But let this get green first. Let me bring it to real time. Yes, now see. So this device has become a single collision domain, and this device has also become, this media has also become a single collision domain, and here also it has become a single collision domain. Now let's send the data. We'll send from here to here. We'll send from here. Oh, wait a minute. We'll send from here to here. From here to here. From this device to this device. And let us see what happens. See the collision. See the collision. You will see the collision only between in these wires. In these two wires, you will see the collision in these two wires. This and this. Not here. You will never see any collision here. Why? Because this is full duplex. And these are half duplex. Half. आज यहीं पे खत्म करता हूं. नेक्स्ट क्लास से आईपी एड्रेसिंग होगी. वी विल स्टार्ट आईपी एड्रेसिंग इन द नेक्स्ट क्लास. यहीं पे खत्म कर दूं ना. क्लियर हो गया ना सबको?
यस सर.
ठीक है. ओके.